We're going to start our year with topic 2, which is atomic theory. We're going to ease our way back into chemistry here. We want to learn or talk a little bit about the timeline of the atom and how chemistry kind of got started. So it all started back in ancient Greece when the Greeks thought the world was only made of what they could see. So they thought elements were things like earth, air, water, and fire. Democritus sat around and just thought about matter and thought that, hey, you know, I bet that matter is made up of indivisible particles. And so that's from the Greek word atomos, which is what he called those particles, we get our term the atom, meaning indivisible. Then a little bit forward in history, medievalish time, you have alchemy. So we knew a little bit more about some elements. You can see some of the elements that they thought of or knew about. Not all of them are correct. And so they started trying to turn everything into gold. So they knew that when you transform something, it can change into something else. And so they were trying to change everything into gold because gold had value. Lavoisier really is the reason we have chemistry. He is considered the father of chemistry. So mid-1700s, he started measuring substances. He realized that reactants and products have to have equal masses, which is where our law of conservation of mass comes from. He defined the element as a substance that couldn't be broken down physically, meaning, chemically, meaning that you can't break up the element, and that's because it's made of the same type of atoms, and you can't separate things that are similar. He also helped give us our nomenclature, so all those naming rules that we follow. In the early 1800s, Daltons started to sit around and think about atoms and matter and how they behaved. Notice that we now have a list of more elements. Again, some of those are not correct. And so he really started looking at the ratios in chemical reactions and things like that, and what he came up with is Dalton's atomic theory. And so we know all elements are composed of indivisible and indestructible particles called atoms. At least this is his theory. Atoms of the same element are exactly alike, and they have the same masses. Different atoms of different elements have different masses. And then atoms combine to form compounds in small whole number ratios. Most of what Dalton thought about was actually true. However, there are some major issues that we now know of. One of those being that we can break down the atom. So if we think about fission, taking the atom and splitting it apart for like nuclear bombs and energy, fission then is taking that atom and it's breaking it and forming two new atoms, or more than two atoms. So they are indivisible. Elements have isotopes. Remember, isotopes are atoms of the same element, so they have the same number of protons but different neutrons. So they have different masses. So he was wrong really in those two major points. Mendeleev in the mid-1800s was arranging the elements to try and make it a little easier to look at all of them, and he found this was his periodic table. Notice that there's some gaps there because he was smart enough to recognize that there are other elements that have not been discovered yet, but he arranged them according to mass, which we don't actually use. We use atomic number, or the protons, so we need to fix that. But he did also arrange them based on their properties, and that's really important when we talk about periodicity. Thomson, in the early 1900s, found that atoms, he discovered the electron using the cathode ray tube. And so we have this idea of maybe what the atom actually looks like. And his model is called the plum pudding model, where you have the negative electrons inside this ball of positive charge. Rutherford in the early 1900s discovered, so after Thomson, around the same time, discovered the nucleus. So he was shooting alpha particles, which are positively charged particles, at a piece of gold foil, which is why his experiment is called the gold foil experiment. And he noticed that some of those alpha particles were being deflected and not passing straight through like was expected. So that told us that there is something positive in the center, and positive meet, it deflects. So Rutherford discovered the nucleus, not the proton, but the nucleus. Bohr, in the early 1900s as well, thought about how those electrons are arranged around that nucleus, and so he has the planetary model. So the electrons are circling the atom. We're going to talk more about Bohr's model later when we talk about spectroscopy and the flame test. Moseley in the early 1900s discovered or was able to determine the number of protons in each of the atoms. That's how we got our atomic numbers, and that's how we fixed Mendeleev's periodic table. Do not worry about remembering people's names and dates. You just kind of need to understand a general overview of how we developed this model of the atom.